By connecting to your code repository, Accurix generates a topology across your full stack to reveal risks so that you can harden your architecture. It also scans code for violations against compliance and security standards to enforce best practices. In addition, Accurix develops threat models using vulnerability feeds, IAM privileges, and other data to predict potential breach paths. Learn how easy it is to get started with Accurix at securityweekly.com/Accurix. That's ACCURICS. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences' next-gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences' patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/Synopsys to learn more.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. We are looking for high-quality guest suggestions for our Enterprise Security Weekly podcast to fill our upcoming recording schedule. We're committed to educating and providing entertainment for the InfoSec community, and we would love to hear from you about who you would like us to interview on the show. Submit your suggestions for guests by visiting securityweekly.com/guests and submitting the form. We review suggestions monthly and will reach out to you once reviewed. Join us at InfoSec World 2020, June 22nd to 24th, now at Disney's Coronado Springs Resort. Security Weekly listeners save 15% off the InfoSec World Main Conference or World Pass. Visit securityweekly.com/ISW2020. Click the register button to register with our discount code or the schedule button to sponsor a micro interview. Oh, and that, Matt and John, brings us to some news of the week. And I think we have some articles in here, too, that are going to be a really good tie-in with the segment we just had with Gareth, talking about mono repos and development processes. But first, my attention was admittedly distracted by a couple of vulns. One in particular had a fantastic Doctor Who reference. So this was called a psychic paper vulnerability that was in iOS. And the thing that stood out about this to me was it was highlighting a inconsistency and mismatch, if you will, to use a bunch of synonyms, in XML parsing. And basically, a application could play around with its manifest and on iOS or Mac OS even, basically obtain more entitlements than it should have gotten. So the entitlements are essentially a blob of XML that gets signed by Apple that says, this is what this application is allowed to do and no more. In this case, playing around with some comment tags, whether they're unterminated or slightly against spec, would basically have one of the 4 possible XML parsers that is present within the iOS ecosystem would interpret them and possibly see the correct or the incorrect entitlements. And so that was one of the reasons that this was really cool and subtle type of vuln that stood out to me.
Yeah, this is an interesting 0-day on iOS that, a lot of people are like, wait, is this really real? There was a lot of talk early on about, well, this isn't really a 0-day, or it is. But I mean, he's made his case in this paper, right? I mean, he's walked through the various steps, how he actually exploited this. This is a pretty significant bug within the iOS ecosystem. Probably one of the most severe we've probably seen in iOS when you think about it, because it's been a pretty good secured operating system. I mean, obviously Apple's, fixing this or in different aspects of patching this, but this was a pretty pretty good. I mean, this has a lot of detail in it, stuff that I it's like way over my head, but it definitely walks through, what was vulnerable, how to exploit it, and some of the issues with entitlements that need to be patched.
Yeah, and you're right. It is a really good write-up. That's the other reason, honestly, I wanted to highlight it, because it walks through that narrative of here's what the problem was, here how it manifests, here what the entitlements are, and here's what the impact of getting those entitlements could be. And the other reason I wanted to highlight, or another reason, is that this type of parsing is often a trap within just programming in general, whether we're talking about the notorious ASN1 parsing or DER parsing in certificates. There's been classic everything from way back SNMP, massive vulnerabilities, to others within ASN1. But the idea that parsing is always difficult. And if you're doing something, try to go a quick and dirty route and relying on regexes, you're probably going to run into problems, because regexes aren't parsers themselves. What you should be building is a parsing tree, something like a recursive descent parser, but something that is to spec, or if the spec, like in ASN1, is pretty complex and confusing, at least it has to be consistent across your platform. And I think that's one of the other reasons that this inconsistency in parsers was what really stood out for me as a good lesson in AppSec.
So I was going to push back a little bit there, and you said the specific word which came to mind to me, which is complex, right? So XML... How many issues have we seen over the years?
Enough said, John. Enough said.
But the point
you just
being,
launched 1 billion laughs with that comment.
if you just look at the I was thinking about sort of the if I can dare say, the older generation of these config languages, first gen maybe, no, not first, that Java gen, I'll use that phrase, really heavy, nasty, heavy resource intensive parsers. And if you think about some of the stuff out nowadays, if you pick your JSON or your YAML or your TOML or whatever else, they're a lot simpler. They're not trying to be this crazy big complex thing with like a style sheet and all these things. And I think it probably goes for any type of application, right, that we talk about on here. As that complexity grows, so does your headache. But I think that's something probably to think about when someone's either starting an app or looking to add something in, like a new config language. Don't get the whole kitchen sink if you only need a drop of water. I'm going to come back to this as we talk about some other stuff, but it's.
Yeah, that's a good point, because just because you're parsing, everyone needs to parse the XML or the YAML or the JSON like you're calling out, but you don't necessarily need to, with XML, to support all of the features. So, and that's, for example, why we have the XXE was such a problem. There's no reason that you're parsing local files that you need to actually go and call out external resources via HTTP, which could then obviously be abused to other things. So there's definitely that aspect of have a consistent parser, but also reduce the feature set to just what you need. And that brings us to a little, we'll save another, we've got 2 more vulns. I'm going to switch to another one called Beware the GIF. And this was about Microsoft TeamViewer, because video conferencing has been on people's minds quite recently. We've covered, obviously, Zoom in 2 episodes ourselves. And in this case, it's a bit of a misdirection, a bit of misnomer, what the underlying problem here was. This is a good write-up that I linked to. I like the description of an exploit. But what the fundamental problem was basically a subdomain takeover. So the issue here is that the way that Microsoft handled authentication and authorization to resources like a GIF, for example, is using JWT. And we talked about some pitfalls of JWTs. I think it was just last episode. And in this case, it's a pretty secure design as long as those cookies are going back and forth within the Microsoft's domains. What these developers or what these researchers found was that they could take over one of those domains, grab a cookie, and then they talk about how to use a GIF and some other scenarios to exploit that scenario. So it's not so much in here there's a GIF parsing or problem with that. It's more of a misconfiguration, if you will, because these types of orphaned subdomains can happen in your cloud deployments. And if someone takes them over, if those cookies are off cookies or sensitive cookies dropping into those domains, then you're exposing your users to account takeover, essentially.
Did I read this one right, Mike? It looks like that an image, the way an image would communicate is a little different than the way it gets authenticated in the APIs. And that looked to be the combination. It needed to be the image leveraging this authentication weakness in an API endpoint that allowed the subdomain takeover. That's kind of how I read it. Is that kind of how this happened?
It's a little bit in a slightly different order. It's more of once you have a subdomain takeover and you can drop your own TLS cert on top of it, then rather than they basically were using the image attack vector as something a bit more novel and curious rather than just saying, here's a link or here's a web page that just loads a resource. So that's why I say that the write-up was a little bit, I don't want to quite say misleading, but I think it's sort of misunderstood what the fundamental problem here is. It's really just make sure you don't have dangling CNAMEs within your DNS infrastructure that someone else go register or take over. They've seen that, for example, this used to be a problem in Heroku several years ago with orphan domains being able to easily take over subdomains because it wasn't clear who the owner. As long as you could register that name, you essentially could prove you had ownership of it. So that's what the real problem was. The aspect of the images and that API was more about how to abuse this takeover so that you could essentially get a victim to leak their cookies to you in some manner.
So I think about this one a slightly different way. And the only reason I bring it up is for those, we've been talking about threat modeling for a while, last few episodes with people thinking about that. So the way I think about this one's slightly different. This is a vulnerability in my mind based off of previews, right? So think back over time. I mean, Outlook email previews, anything that you can get someone to auto load an image from somewhere else. Remember when we started initially having pixel tracking for tracking down bad guys in emails, all these different things, right? It's that idea of being able to preview something from a third-party site. So the reason I mentioned in threat modeling, right, is if people are thinking about, hey, I want to put a preview in there or something, what can someone do with that? How can they actually play with that? What can they do with your client, which is going to render that image or video, GIF, or these type of things? So that's what was interesting about this to me. And I guess the question for me back to you guys, I've heard a few times over the last few months about these domain takeover type attacks. And it seems like they're always like, oh my God, terrible thing. Is this as big a deal out there as, not like, I understand it's a big deal. Is this as prevalent and common and as easy to do? Because someone was like, I don't know, a few months ago was like scolding Microsoft for not shutting down old domains. I've seen a few different things like this, but it doesn't, I mean, that seems like that should be pretty minimal. Is this really a bigger deal?
Yeah, the way I've seen it, it was in vogue for a year or two within bug bounties. So all the bug bounty platforms were full of people finding these misconfigurations in a GCP or AWS or Azure. Pick your cloud provider, or Heroku was the other example I saw. But then somewhat like the metadata services, the cloud providers have basically put some extra checks and some other ways that mitigate this. So you can have a dangling CNAME, but it's a lot harder for someone outside of your organization to go in and take it over, or there's some additional barriers they have to overcome. So this case was actually pretty interesting because it was still, I believe it was still just a what if scenario. So they're saying if we were able to fully take this over and drop a cert on there, we could have done this. I don't know how much it actually was truly impactful. Clearly, it's something to be fixed, but I think it's one of those things, if we go back to threat modeling, that it is the impact of it is far reduced, or maybe I should say the likelihood of it being exploited. It has been reduced by a lot of additional controls that the cloud providers have put in. But clearly something to keep an eye on, and because we're always looking for, one, interesting write-ups that are good and informational or educational to learn from, as well as who out there is being clever and creative in ways of putting together vulns that are creative in unexpected ways. which leads us to the third vuln I wanted to talk
and
about.
your favorite. I mean, you've been waiting.
My favorite.
I'm surprised you waited this long for this one.
I was building up the tension, exactly. But unfortunately, it wasn't too exciting because it's directory traversal that was pretty easy to pull off. So basically, it just forgot ... and missed a canonicalization within SaltStack. So you're able to poke around and change and get access to essentially arbitrary files on the file system for the SaltStack, for the, I believe, the routing server. And the other vulnerability here was also a pre-auth bypass that, again, basically boiled down, in both cases, one, forgetting to canonicalize and normalize your data before applying security checks. So forgetting to normalize any presence of ... directory traversal. And the other one was just a mistake in coding that was exposing basically what should have been authenticated access endpoint or functionality that just got accidentally exposed to an unauthenticated manner. So two very simple types of vulnerabilities. So unlike the bit more complicated discussions, attack scenarios we were just talking about in the previous ones, but still pretty straightforward and simple to exploit.
Are they easy to fix? Because this write-up says, look, we could have exploits here within 24 hours of these vulnerabilities being disclosed. I'm assuming SaltStack is already working on a fix to fix this. But is it an easy fix based on what you know, Mike, or is this going to take a little bit of time to resolve in the code?
No, I think in this case it should be a pretty easy fix because one, the normalization of paths is a relatively known problem. I can't say it's a solved problem because obviously mistakes are still happening. But I think in both cases it's an easy fix to deploy or easy fix to implement. It has to get deployed, and that kind of speaks back when our conversation with Gareth about it's one thing to know there are vulnerabilities out there. So visibility is great. And so hopefully, all of our listeners now know about this problem in SaltStack, but they have to actually go about and apply the patch.
Right.
So speaking about, I'm going to talk about IoT real quick, but I think that we should get to your article, John. And the reason I wanted to mention IoT, we talked about it last week about the Internet of Medical Devices, and I came across this article from Microsoft that was talking about IoT security and managing risk within IoT, and it linked to a PDF where they call 7 properties of highly secure devices. And now I think the properties are good, but they're a bit high level and a little bit generic, so to speak. So they're more of if you're just starting out to try to figure out how should we align the way we're thinking about risk for IoT, or honestly just app development, AppSec in general. Talking about roots of trust, small trusted computing base. Then it talks about defense in depth and compartmentalization. These are not earth-shattering and not new by any means. And they talk about also certificate-based authentication, which I think is great, but it's also one of those things that's not trivial to implement and deploy at scale. We have tools like Let's Encrypt that can help with this. But it definitely hand waves over a lot of the complexity, to use our word of the day, on actually how to do this in practice. So good something for thought, but I don't know that it's really there's still some things that are going to be hard to implement for IoT.
So a few thoughts here because I really love what Microsoft's doing with IoT. The first is a fun one. This 7, what's the actual title of it again? The 7 properties.
Devices.
Yeah. So the fun thing about this white paper, you can make a drinking game out of this one and go to like Microsoft's site on IoT, and they mention this paper everywhere. So like, soon as I saw the link you had to this, I'm like, oh, it's gonna mention that paper, and it did. But that's just sort of fun. It's okay. It's high level, but they have another paper on there. They did a oh man, if I think of it, I'll see if I can add it into the show notes. They did another where they had a third party do research around IoT and sort of state of security of. That's a good one. It's like 25, 30 pages, pretty well done. They're doing a bunch of really great stuff, as I've said two times already. But in particular, the 7 points you're talking about here, I think you might have mentioned Sphere. I know they mentioned in there. That does all of these things. But my comment then when I was looking at this and thinking about it last year is, it's what's adoption going to be like? I think they've left it. I think Microsoft's IoT play is sort of interesting, where they're really thinking about purely the industrial side, like the larger industrial, where people are willing to spend. Because I think that the Sphere device is the most expensive one I picked up in my little collection. But if you want to do it right, that's a really nice blueprint on how to do it.
Yeah, so absolutely a framework rather than it's not the equivalent of here's your implementation guide. It's definitely that framework.
Yeah,
and maybe
I guess.
Mhm.
Well, final thought on there. Just I don't want to scare people off. You don't have to do all the things which the paper recommends, right? So they have. And promise, I'm not shilling for Microsoft, but they have a bunch of components out there. Their message queues and their different pieces, so you can do some of these pieces individually, either on Microsoft or on Azure or on AWS, or pick your partner. But if you want to go to the pane, or if you need to go to the pane, you have that use case. They've got a decent solution for that as well.
Yeah. Well, I think, so speaking of going to the pain of development, let's talk about trunk-based development. So you highlighted in particular this article, John, and I think it's interesting because, and I'll just preface it here, then throw it over to you, just to tie it into our discussion with Gareth, because we're talking about, he brought up monorepos and dependencies, and even in your monorepo versus microservices, do you only ever have that one version of OpenSSL, or have some compiled in binaries snuck in because other teams are working on something and they can't be bothered, or they don't have the time to fix a downstream cascade of bugs that are coming in? So I'm going to a little bit foreshadow my thoughts on this.
So, and I put this in here, really, this is a discussion, let's see how much things I can bring in here. For our listeners, we are bringing out a Discord server, and we want our listeners to come and enjoy or have a conversation with us interactively in all the different Security Weekly podcasts and shows. We've got our own channels on there. So I'm really looking for people's feedback on this one. We're about to show you a very particular, I think, incredibly strong flavor of Kool-Aid. And that's this idea of trunk-based development. So in a nutshell, the idea here is you don't use feature branches. So what that means is everyone in your team, for whatever the size of that team is doing their commits and pushes directly against trunk. The paper I found here on this sort of, they lay out some good use cases for why you might want to do this. As those who watch the video and know some of the looks of WTF I get on my face, you can imagine what it was like reading this paper from me. Some point down the paper, they mentioned pair development, pair development. At which point you go, it's related to that flavor of Kool-Aid. So this is something only, I think, a very few, very dedicated number of teams are going to think about doing. It's interesting. I don't know. That's sort of where I left it at, guys. I'm curious. I don't know, Matt, if you got a chance to look at this. Mike, let's hear your point of view.
I looked at it a little bit, because I haven't developed in a long time. This one's harder for me to wrap my head around, right? I mean, I can see potential advantages, but I'm trying to still understand all the pitfalls, right? Yeah. I know that merging code from different branches can be a pain in the butt, because I remember when Sean used to do this for me when we were doing the startup. And if you're coding if you're just coding everything to trunk, does it make that whole merge process easier? Even Paul's had issues with merging of our own code, right? And so merges are a pain in the butt. But where's the downfall?
So I'll jump in on that. Merges, from my point of view, they can really bite you on the butt. I think if you have both branches maintaining and keeping in sync, then the merge usually isn't that bad. Not always, but usually. But that is one of the pitfalls which was mentioned. How you do code reviews is different. How you do feature development, large feature development in general, is different. And I think we'll see what Mike has to say, but this comes back to one of the things I was daydreaming about when Garrett was talking too. But Matt, you had some other thoughts on there.
No, I was just like I said, I know the merge is a pain, right? But if I'm coding everything to the trunk, and I've got good automation routines in place that's constantly validating that trunk as it goes through, maybe I can account for some of that downside. But that's where my big question is.
Yeah, and that's where too I think this works better if you have a more mature organization that has embraced this and supported it with tooling that can do better series of tests, both from that initial commit all the way to a build, to a canary build, to a canary deployment, so that you can find a lot of these undiscovered or unexpected interdependencies early on, and get them fixed. So it's not necessarily a bad thing, I think, in my mind. It just means you have to put a lot of effort into catching a lot of problems that can happen, and then being able to roll out a fast, fix forward type of approach, so that if something does blow up, then you can respond quickly. And even this article was talking about, it's referring to sort of like organizations that are releasing multiple times a day. So already, I think you're working with organizations that have a lot of this automation in place. There's some things too that can help you with this. For example, if you adopt feature flags, so that way you can develop against the code base, put the code out there. It's sitting, it's baking, it just sits for a couple days, maybe even a week or so, but it doesn't do anything except sit there until and make sure that it's not interfering with other services, it's not changing something that was unexpected. Then you can actually just flip the feature on. And so if you have also that type of maturity and capabilities, I think this type of trunk-based development can be successful for you. As the one thing that always comes up in my mind here, which I think this was a great tie-in to our discussion with Gareth, is that it does introduce, though, that idea of enforcing you break it, you bought it kind of dev mentality. Meaning, if you have to make one change or in a dusty area of the code, how much of that cascading effect and problems or burden then do you bring onto yourself? Because maybe that one change is some duct tape over some previous duct tape over some previous duct tape versus a really well-designed interface or component. It's also the problem with, and we're just going to pick on OpenSSL just because it was brought up in the previous segment, but let's say you do have a vulnerability in OpenSSL, or OpenSSL has just been updated. Sure, it's not a direct dependency of yours because you're in a different area of the code base and your feature doesn't even touch on that. So who becomes responsible for that? So there does need to be either the idea of a dedicated, call it a framework team that's curating or gardening the entire mono repo and its dependencies, or there has to be some team that, and here's where you're sort of relying on that diffusion of responsibility, which may not be the smartest thing. You're relying on somebody to notice that, oh, hey, look, that's out of date. I need to go. Nobody else is going to do this, or I saw it. I'll go and fix that. And that's one of the dangers that I see, is just there should be a process or some way to have a mechanism around that, so you don't accrue tech debt in, call it more stable but untouched areas of that code.
Yeah. So feature toggles is what I was thinking about when Garrett was talking before. And where that was sort of interesting to me is some of those examples we were talking about of a really large, back to a complex framework, right? Like React is the one I was thinking of. You might be using a very small, and most people are, right, using a very tiny section of React. Why can't you feature toggle the rest of that thing off? And then the second thought I had around there, I started thinking like, okay, is there any examples of that I can think of? PHP actually, to a degree, right? So in PHP, you're able to, besides setting your, and probably more because it's server side, but besides setting your limitations for resources, you're able to toggle a lot of things on and off. So it's still just a thought process for me, or a thought experiment, but is that something which some of these larger frameworks could use with? I mean, probably same thing in OpenSSL. Do you need to be able to support all these different either ways of parsing a certificate or generating a cert? Or can you say, well, I guess you can't have defaults in OpenSSL, bad example, but in some of these things, could you actually limit those down a little tighter?
Yeah, I think that's a great, because that even when we were just talking about libxml, just being able to have feature flags so you configure to turn off external entities. And that's the whole point with OpenSSL. That was the whole point of boring SSL. That implementation said, rather than toggle off now, since they're not off by default, we're just going to get rid of a lot of functionality and a lot of these weird ciphers and algorithms that no one in their right mind ever should use, let alone they were in there more for just kind of curiosity's sake and completeness than proper security, as well as even just getting rid of a lot of, here are some chipsets with some assembly that we don't even need to support, and so aptly named boring. It also makes me think of, though, if you have those configuration settings or feature flags, if we're talking about like this type of custom development, I think that's good because you can control what you're doing with your features, rolling them out. It does make me think, though, our conversation about Kubernetes, and that by default, it has a lot of things turned on that you're able to do, that maybe you should have those turned off by default. And maybe that is sort of like, let's push on Kubernetes to actually have that off by default so developers don't have to go do that themselves.
Yep. So one of the things I'm working on in all my spare time right now is part of a working group for Cloud Security Alliance's outcoming paper on securing serverless compute. So I've been going through some of the cloud providers and looking what controls do they have available. But to sort of circle this thing back to what we were just talking about, the Azure and Azure Sphere, one of the things they've got into that framework is the ability to, it's sort of like what we were talking about before with the XML bug on Apple, the ability to actually specify these are things that we want in this particular release. So, kudos to Apple for trying to do the right thing. And unfortunately, they used XML. But maybe that's what we need to see more companies doing something like this.
We're going back to text files and VI. Let's do it.
Yeah.
Well, I did want to, but before we wrap up, it is May 4th, and so I figured that it was important to acknowledge that date because back in 2000, this was one of the biggest viruses to hit in the early days. So the "I love you" bug. So yes, there was a little bit of a misdirection there. It wasn't the reference you were thinking of or you were looking for. But this was just interesting. So 20 years ago, on Windows 95. This was just a guy who wanted to get more internet access for free. So he wrote a virus and that essentially was grabbing people's credentials so that he could use it on dial-up or what have you to get internet access. And so the BBC has an article about a book that's also coming out soon about this particular virus and others. So I just thought that was a pretty topical connection here. And also a long time ago for talking about Windows 95 bugs back in 2000.
Yeah, in dial-up. Yes, folks, we used to use dial-up modems to get to the internet.
That's right. I won't put John on the spot to try to emulate the what that modem sound is like, but we'll just say that we're out of time, and I'll just say we'll just imagine that it happened. And I want to say thank you, Matt, thank you, John, for joining us. And I want to thank all you listeners for joining us and to assure you that indeed no Bothans were harmed during the recording of this episode. We will dispense with the pleasantries and put you back on schedule next week with Application Security Weekly.